All right, so a student dissolved 0.212 moles of iron 3 chloride to make 175 ml solution. Find the molar concentration of the solution and the concentration of the ions in the solution. So it's basically three things you're looking for there. First, before we do anything too mathy, what are we going to do? That's right, our dissociation equation. So let's write that out. We have iron 3 chloride. Actually, we start off as a solid. Then we put it in the water, and it becomes iron plus 3, aqueous, plus 3 chloride ions. Everything is nice and balanced here. And I'm going to write down my information. So I want to find concentration of this. So C is equal to N over V. C is equal to N over V. Okay. I have my volume already. So volume is already given to me. I'm going to write my volume is equal to 175 mils. And that's approximately 0.175 liters. Okay. And I also want to try to find the concentration of this because it says to find the concentration of the solution and the ions. So by the end of it, basically what I want is concentration of FeCl3, concentration of Fe plus 3, and concentration of Cl minus. That's what I want at the very end. So I want C is equal to N over V here. So like I said, this problem can be done in the exact same way that it's done over here. You can do your mole ratios. So find the number of moles of this, then divide by the volume. Find the number of moles of this, and divide by the volume. But there is another way to do this. So I'm going to show you the alternate method. But for homework, for extra practice, you can try the method up here to see if you get the same answers in the end. So this other method to do this is to find the concentration of your initial solution, basically everything together. So you have the moles over here, 0.212, and you have the volume. So you can just do C is equal to N over V. So C is equal to N over V, which is equal to 0.212 moles, divided by our volume, which is 0.175 liters. So 0.212 divided by 0.175. And we get 1.211428571 moles per liter. And right away I have the answer to one of these. I'm going to go put it in my little line over here. I think it's 3 sig figs it needs to be. So about 1.21 moles per liter. Okay. Now, in a question like this, you can actually do a mole ratio with your concentration. Providing that the volume stays the same, like you're not adding other volumes or other solutions there. As long as your volume is always 175, you can just take the straight up mole ratio, the straight up concentration you calculated there, and do a mole ratio with it. Okay, so that's how I can find my concentration for the other ones. So for example, here, my mole ratio between the FeCl3 and the Fe plus 3, what is it? Yeah, it's a 1-to-1. So 1 FeCl3 for every 1 Fe plus 3. So since it's a 1-to-1 ratio, the concentration of Fe plus 3 is equal to the concentration of FeCl3, which is equal to the 1.211428571 moles per liter, and to the correct number of sig figs, about 1.21 moles per liter. So notice that I don't have to do the C is equal to N over V 2 times. I can just do it once at the beginning for the initial compound, and then use the mole ratio to find the concentration of the ions there. That's again assuming that the volume does not change. It's only in these type of ion dissolving type of problems that you see here. Okay, that's when you can do that. You can use the longer method or the shorter method here. Okay, so let's do the same thing now, but for the chloride. What's the ratio between the FeCl3 and the chloride? Right, yeah, a 1-to-3 ratio. So we have a 1 FeCl3 to 3 Cl minus ratio. So we can just take the concentration of the FeCl3 and basically just multiply it by our proper ratio. So we could do 1.211428571 times 3 divided by 1. So this would be the, sorry, let me erase that and make it more clear here. This would be for the FeCl3 times 3 Cl minus for every 1 FeCl3. We can cancel that out there, and we're going to get about 3.634285714 moles per liter, or to 3 sig figs, 3.63 moles per liter. Now, what do you notice about the concentration of Fe plus 3 and Cl minus? How are they related? How does Cl minus compare to Fe plus 3? Right, 3 times larger. And why is that? Why is that significant? Why does that make sense? Because it's a 1, right, see over here, it's a 1-to-3 ratio. So technically, once you find your Fe plus 3, you could also just multiply it by 3 to find the Cl minus here. Because there's 3 times more Cl in your solution than there is Fe3 plus. So basically, it kind of looks like this. So if you had your beaker, we have 175 mils here. You would throw in some solid FeCl3, and basically you'd have an Fe plus 3 here, and then you'd have 3 Cl minuses swimming around. Now, it wouldn't be exactly 3 and 1 because there's more than that, but it's in that ratio there, right? So you might have 6 and 2, right? Or 6 moles and 2 moles, for example, or 3 moles and 1 mole, for example. Okay, so that's what it kind of looks like in there. And so they have different concentrations because you have, you'd have a higher concentration of Cl minus because there's just more there that dissolves because there's 3 in that compound. And then you have a lower concentration of the Fe plus 3 because there's only 1 in that compound. So that it contributes a little bit less to the concentration of that solution overall. Okay. But again, it could have been done in the exact same way that we did it in the previous question. All right. Are there any questions about that one right now? So this was ion dissociation questions. Before break, what we're going to do is we're going to take a look at the first example in the concentration to mass problem. That'll be a first example of a stoichiometry type where there's a reaction happening. Okay, so no questions about that for now.